Are we rolling? I think so. Well, hello everyone. In today's video, we're going to be covering the first part of logarithms. As you can see there, you've got a log and you've got rhythms. It's logarithms. But today we're just covering the simple part of logarithms, the very beginning. We're going to cover the basic formula like log A plus log B, and we're going to be covering how you can sort of rearrange the equations to find logs. So we're not going to be looking at, E, we're not going to be looking at natural logs, we're not going to be looking at the graphs, just these simple equations. So, you can figure them out. They're quite fun to rearrange once you know how. So I think to start off, we need to first explain, what is a log? What is a logarithm? And I don't mean a tree or music for that matter. What is a logarithm? Well, the standard form for the logarithm is log base number equals power. Now, you might be able to guess what that means, but, when I never saw this, I couldn't. All I saw was BNP, made me think a bit of bananas. Honestly, I'm not going to lie, it made me think of a bit of bananas. But bananas have nothing to do with this. What this means is, well, let me just write a number example actually, it'll be easier. So log 2, 4, right? Now, pretty simply, that just equals 2, okay? And obviously you don't know how that works right now unless you've done this before and you're just here for the giggles. But basically, what you're trying to ask is, to what power do you have to raise the base to get to the number? So, what power of the base equals the number? So as you can see here, the power is 2, the base is 2, the number is 4. And what you get from this is 2 to the power of 2, so 2 squared, is equal to 4. And these say the exact same thing. They're literally the exact same. It's just different ways of writing. That's all a logarithm is. It's a different way of writing this. And this is what is known as exponential form. So if you ever asked to write a logarithm in exponential form, you write it like this. You simply, write it as you normally would. But a logarithm, the reason they made them is they're good for estimating large values and tiny values. Like we're talking, use in particles, use in galactic scales. We're talking big numbers, like say Planck's constant or something. And obviously on smaller scales as well, but this is what a logarithm is. To what power do you have to raise the base to get to the number? What power of the base equals the number? So 2 to the power of 2 equals 4. So let's look at another one real quick. You've got, well, I'll give you a few to look at. I'm going to see if you can get them just from what I've explained there. So if I had log 3, 9, for example, there's one for you to try if you think you can get. And I'll give you a couple more, you can pause the video and have a go. But log 4, 64, we'll do a big one. And then we'll do, I think this one will be good. Log 9, just 81. Now, some of you understood that right off the bat. It may seem a bit easy, but some people don't get it, quickly. I didn't catch on too fast. I caught on quite quick, but not immediately. I thought they were a bit confusing as well. But the answers to these are quite simple. To what power do I have to raise 3 to get to 9? And that's my answer. To what power do I have to raise 4 to get to 64? And, the way you do this is simply 3, 3 squared is 9, so the answer is 2. This one, 4, you've got 4, 16, 64. 4 cubed is 64, so the answer is 3. And log base 9 number 81 equal to what power 9 to what power equals 81? It's 2. So you've got 2. Now, that's the fairly simple part of logarithms, and I quite like it. It's pretty good. You know, you can make some flashcards. These I find flashcards for logarithms like this are very good, very useful. But essentially, just remember, to what power do you have to raise the base to get to the number? And yeah, you should be fine. You know, they're not bad. They're quite fun. As I've said a few times by now, I'm sure you're getting fed up. But yeah, they're enjoyable later on, trust me. But yeah, as I mentioned before, there's something called the exponential form as well, which is equal to that. And we saw that log base 2 number 4 is equal to power 2. So how would you write that in a general form? Well, exponential form, you know, if I write this out, exponential, you can't really read my writing because I'm not that good at it. You know, decent at maths, bad at writing. I never got my pen licence, I'm going to be completely honest. And I had handwriting lessons in year 9. But exponential form, you have, essentially, you're going to convert this back to the simple form that we all know and love and that we can all use. It's lovely. So you have, when you're looking at this, you obviously ask, to what power must I raise the base to get the number? So then, essentially, you can just write it as b to the power equals n, or the base to that power equals n. So that's the exponential form. If I wanted to write log, you know, as we had before, log base 2 4 equals 2, how would I write that in, you know, exponential form? Well, you have, this is p, so that's p, that's n, that's b. Looking at this, you've got 2 squared, you know, the base to the power is equal to n, which is equal to 4. So we've just converted that to exponential form, which is quite simple, but the thing is, these can get a little more tongue twistery almost in your mind, brain twistery if you will, later on, because you can have multiple, you know, on a line, you can have like say 4, maybe 5, and you've got to figure them all out. You can make mistakes converting to exponential form, so you know, be a bit careful with doing it. But yeah, you can convert to exponential form. Now the next part is to do solving equations, which is the more fun part, I think. And you've seen the two forms. You have logarithmic form, exponential form, mean the same thing, and we're going to see how you can do an equation that has logarithms in, not with exponents, not with the exponential form anyway. So say you had log base 2 4, we know that's 2, don't we, plus log base 2 of 8. Alright, so now you could solve that just converting as normal. You know, you could just say, well, log base 2 of 4 is equal to 2. You know, 2 raised to the 2 is equal to 4, so that's just 2. Log base 2 of 8 is 3. So you have 2 plus 3 equals 5. That's all that's equal to, 5. You can follow that, it's fairly simple. But now if you have, say, well, first of all, let me see, would this work? Yeah, it would. Alright, but there's another way to do it, right? The standard formula for this is log A plus log B, I'll move out the way in a sec, don't worry, equals log AB. You know, looking at that, you've got log A plus log B is equal to log AB. Now, looking at this, what's our A? What's our B? Well, A is 4, B is 8. So in this scenario, it would become log base 2, 32. Alright? Because 4 times 8, sorry, that may be a bit confusing, I jumped the step there, but log base 2 of 4 plus log base 2 of 8 is equal to log base 2, 4 times 8, due to this. So you get log base 2 of 32. Now, 2 to the what equals 32. You know, the base of 2 to what power equals 32? 5. Don't come in. Sorry about that. But log base 2 of 32 is equal to 5. So yeah, there. As you can see, these are equivalent. So obviously we know that works. Of course it works. That was made by a much smarter person than me. But we know that that standard form works. So let's look at a couple examples of that real quick. You're going to have log, what could we say, log base 3 of 9 plus log base 3 of 81. Okay. So what would that be? Well, that would just be log base 3 of 9 times 81, which is equal to log base 3 of what? 810 minus 81, which is 729. Yeah, log base 729. And now from this, you could plug that into your calculator, or for me, I'll just, you know, that's 2, that's 4, yeah, 4, so that's 6. Log base 3 of 729 equals 6. And this works for any log, but the important thing to note is the base must be the same. So say for example this was 2, you know, I've changed that to 2, log base 2 of 81. You can't just do them multiplied together. You have to sort of figure them out separately, or there is other ways to figure it out too, I believe. But yeah, you know the formula now. It's log A plus log B equals log AB. You know, you can see the sort of plus as them coming together, and the A and the B, they come together, you get AB. But now there's 2 more standard formula as well. I'll cover the A minus log B has its own formula, which is equals log A over B. Alright. Okay. So how can we use this? Well, if you have log base 2 of 4, well, we won't make it, you know, simple. We'll do log base 2 of 6. We can't just figure that out on our own. Minus log base, let me think, well, log base 2, so obviously we want it to work. Log base 2 of, can't really think of a nice number. Let's do a random one then. 5, log base 2 of 5. Okay. Now what's that equal to? Well, that's going to be equal to log base 2 of 6 over 5. Okay. So now we can plug that into our calculator. I'm not going to, because, you know, that's equal to whatever the calculator will put out anyway. You know, you can just use that in an equation and it'll be fine. But, you know, if you want the sort of decimal answer, then you can put that in. But this is more exact. Use this in your equations. So, yeah, that's the same as the last one. I don't really think we need to cover much there. It's just, you know, it's a pretty standard formula. You know, you can practice it yourself with some examples. You can find them online. I'll probably give some at the end of the video too. But yeah, there's just another formula. Alright, and there's one final, formula, standard formula that I'm going to show in this video, I think. Yeah, I'll show one more. Maybe two. Probably do one. But log, if my pen would like to work, we might have to switch to a bright, colourful one. Log base, log, we'll do algebra, log A to the power of log B. Right, what is that equal to? Well, quite simply, that is equal to B times log A. So log A to the power of B is equal to B log A, and that's very faint. I don't know if you can see that very well. I'll just rewrite it in red just to make sure. That's much better. Much better. Equals B log A. Yeah. So log A to the power of B is equal to B times log A. Alright. So what we can do with this then is we can sort of simplify our logarithms a little. You can also figure stuff out with them, but log, say log 2 cubed. Well, we'll do big numbers because that's easy to figure out just in our heads. Log 2 to the power of 64. Yeah, big one. Plus log 3 to the power of 29. What's that equal to? Well, not only is that equal to log of 2 to the power of 64 times 3 to the 29, but it's also equal to 64 log 2 plus 29 log 3. Also, by the way, I do want to mention I didn't use bases here, which was a mistake on my end, you may be thinking, but if you are given a question that doesn't have bases, so there's nothing there, you take it as 10. So these are actually log base 10. It's the standard, basic log that's there. So they're log base 10. If there's no number there, no base, it's just by default 10. So yeah, you can rewrite this as this, and it's a bit simpler. But yeah, using that then, say you wanted to, looking at this, you're probably thinking, I can't really divide that by anything, I can't really simplify it. Well, if that was a multiple of 2, then you could divide all this by 2, and you'll get 32 log 2 plus, just make that 30, plus 15 log 3. So if I was to change this to, 30, right, since I've gotten this down to this form, this is just multiplying by these. I can now actually simplify this to 32 log 2 plus 15 log 3. So you're actually able to simplify if you get it in that form. But yeah, that's another formula. So I'll write all the formula I've covered so far down for you just to get a quick little snapshot. I'll write them just up here. So log A plus log B equals log AB. Just coming on to my logarithms there. But log A minus log B equals log A over B. And then log A squared is equal to 2 log A. Well, we'll do that as algebra, just so it works for any case. Yeah, so there your standard form. It might be a bit hard to read because my handwriting's bad, as I mentioned, and a bit small. But Anyway, we've learnt our three standard formula now, and as I said, you can solve sort of equations with logarithms. So I'll see if I can think one up right now, just off the top of my head. So if I was to have, say, log x, these are all to the base 10, the default, minus log x squared, minus log x squared, so I'll write that a bit bigger, minus log x squared plus log y, right? So you have log x minus log x squared plus log y. Now, how would you do this? Would you use BIDMAS? What would you do? Well, quite simply, the quick way to do this is you look at which ones have a positive symbol before them. So that's, got an invisible positive there, and which ones have negative symbols before them. And so the way you would do this is, in this, you multiply the positives together and then you divide by the negatives. So you would have log x minus log x squared, so that's the negative. These two are the positives, so it would just simplify to log xy over x squared, which obviously you can simplify that further to just log y over x. So yeah, in these scenarios you just put the positives as the numerator and the denominator is the negative logs, and that's how you can simplify them down the quick way. So if you had to say log z squared minus log y plus log x minus log z. Alright, how would you simplify that? Well, you put the negatives on the denominator and the positives on the numerator, so this would simply simplify to log x z squared over z y, which simplifies to just xz over y. Log, there's a log there. But yeah, it's quite simple, I would say. We'll look at an example with a number, but I'll just show you how this works real quick. Because obviously it might seem a bit confusing, where's he getting, put those on the numerator, put those on the denominator from, makes no sense to me that. I didn't learn that before. Speaking nonsense, speaking baloney. Well, quite simply, you have log z squared minus log y, which is just log z squared over y, right? And then to that you are adding log x over z, right? So now what do we know about adding logs? We know that you just multiply these together. So you get log xz squared over zy, which is the same thing as that down there, isn't it? So it's just the quick way of thinking about it. The negatives, denominator, positives, numerator. And I'll show you real quick an example with actual numbers rather than the English language. Even though it's a pretty funky looking Z, but it's how you distinguish it from an S. Right? So if we was to have log 2, right, minus log 4 plus log, say, 9, right? How would you solve this? You know, you can have a little go, you can pause, have a go if you think you can understand it. If not, then I'll show you now. So this will simplify down to log 2 over 4 plus log 9, right? So then that's just a half. So you have log a half plus log 9. Now that's equal to log 1 over 2 times 9. Now that's just log 9 over 2. Alright. So we've simplified that down to log 9 over 2. We've gone from this down to this in a couple simple steps. And I think, for the most part, that's the fundamentals, but you know, you can get a bit more complex equations and you can play around with them a bit more as well. Like, for example, you can solve for, say, x in the equations. You know, I was using algebra before. If you have some algebra, some actual math numbers, then you can actually solve for those values. So if I have log of x is equal to log of, say, 2 minus log 6. Alright? So very simply, this is just log x, right? This remains log x because it's on this side of the equation. Log x equals log 2 over 6. Okay, so we know that log x equals log 2 over 6, which is log 1 over 3. So log x equals log 1 over 3. So then what's x? Well, come on, it's 1 over 3. X equals 1 over 3. So we just solve that there quite simply. You can get far more complex ones, like I'll show you one more and then I'll give you some, you know, sort of questions to take home with you. I'll actually post them in the comments, I think. It's just easier. You know, I can think about them more thoroughly then. But yeah, one more complex example is sort of log x is equal to log 2x minus 3 minus log x plus 2. Now we can look at this. Now obviously we know what that's going to be from our formula, don't we? You have log x is equal to log 2x minus 3 over x plus 2. Okay? So you get x equals 2x minus 3 over x plus 2. Yeah? Seems pretty fair. You get x squared plus 2x is equal to 2x minus 3, which can simplify down to x squared plus 3 equals 0. Because obviously you subtract 2x from both sides, add 3 onto this side, x squared plus 3 equals 0. So then, yeah, you actually end up with an imaginary number in this scenario. You get x is equal to root minus 3, which obviously, you know, isn't possible unless you look at imaginary numbers. You know, you can plug that into a calculator and it'll give you an imaginary. Well, actually, it'll give you an error. But yeah, that's an imaginary number. It's equal to root 3i. Yeah, root 3i, you know, the imaginary symbol. But we're not going to go there today. That's another whole can of pineapples. I get it, because pineapples, not worms, pineapples. Quite like those fruits, you know. But yeah, that is in summary logs. There's not much else to cover in this video without going over natural logs. I don't want to make it, too long. So I'll probably do another video covering natural logs, which make it even more fun because they involve e, the exponent. They involve, basically it's logarithms using the exponent, if you've seen that before. But some cool stuff happens when it comes to working with the equations and finding values and everything. It can be really fun. But yeah, that's all that we're covering today. Some simple solving logarithms. I hope this was helpful, and I hope you enjoyed the video. If you did, then please, show a little support. If you want to see more videos like this, then turn on notifications after subscribing. If you liked this video specifically, hit like on this video, and yeah, stay in tune for more if you like maths and physics. And yeah, that's all I can really say. Hope you enjoyed the video, and hey, 19 days until Christmas. Have a merry season, everyone.